Greetings, math people. Today we will be deriving several geometry formulas. So at some point in school, in most cases, you're kind of given these particular geometry formulas and you just accepted them thinking, yeah, it must be true if that's my teacher telling me it or if it's embedded within some book. And so today we want to derive the formulas and kind of show you where they come from. Well, we're going to derive the formulas using calculus. So of course, there's different ways to derive these particular formulas. But we're going to utilize calculus. We think of all our studies, calculus is most utilized to reward our research. So let's go ahead and dig right into this. All right, the first formula we will derive will be the formula for the area of a circle, which you know to be pi r squared. And so we're going to do this with utilizing area under the curve. So let's say I have some function. Well, let's say I don't have a function. Let's say I have an equation of a circle with a radius of r and the center at the origin. So x squared plus y squared equals r squared. And so what I'll do is I'll solve this for y, where y would be the square root of r squared minus x squared. And so the graph of this function, say that's negative r and say that's r, will look something like this. So the way this is constructed, this is the graph of a semicircle, not a whole circle. So when I do what I'm going to do to find the area, basically what I'm going to do is going to find the area under this curve. I'm just going to multiply by 2. So of course, area under this curve from negative r to r would be integrating this function from negative r to r. Now bear in mind, r is just some number, r is a number. So therefore, the area then is 2 times the integral from negative r to r of the square root of r squared minus x squared dx. All right, so that's the calculus way of finding the area. Now again, since I'm multiplying by 2, it's going to represent the area of the whole circle. All right, so this is not the most elementary integral to do. It's not the hardest either. So what I'm going to do is I'm going to say let x equal r sine theta, which means dx would equal r cosine theta d theta. So what will happen is when I'm going to do the substitution. And so I think I got a little space to play with. So before I go to the new sheet, let me kind of fit this in on the side over here. So if I do the substitution, this new formula becomes 2 times the integral. Well, let me not substitute just yet, because when I substitute this in forms of theta, I want to put what the new limits are in terms of theta. These limits are with respect to x, and so I want to write the limits with respect to theta. So let me hold on there just for now, and let me manipulate this a little bit. So if x is r sine theta, then that means sine theta is x over r. And sine, of course, is opposite over hypotenuse. And so if you look at a right triangle, would say theta there, this guy would be x and this guy would be r. And by Pythagorean theorem, the adjacent side would be the square root of r squared minus x squared. I might not even need that bit of information, but it was just so tantalizing, we decided to place it there. Anyway, now here's the thing. So I'm going to rewrite these limits in terms of theta instead of in terms of x. So what I'll do is plug in r for x and negative r for x and see what the corresponding values for theta are. So if I plug in r for x, sine theta would be r over r, which would be 1. And so if sine theta is 1, so when r equals 1, then theta is pi over 2. And if I plug in a negative 1 for r, then sine theta would be negative r over r, which is negative 1, which means sine theta would be negative 1, meaning when r is negative 1, theta would be negative pi over 2. So sine of pi over 2 is 1. Sine of negative pi over 2 is -1. All right, so I'm going to change these limits from negative pi over 2 to pi over 2. And then I'm going to go ahead and substitute r sine theta for x and r cosine theta d theta for dx. All right, so I'm thinking I'm going to have to do that on a separate sheet. So let's do that. So a is going to be 2 times the integral from negative pi over 2 to pi over 2, and just show you what I'm doing. So when nothing's happening just yet, minus, excuse me, the square root of r squared minus. All right, so let me just show you what's happening. So this is r squared minus x squared, but x is r sine theta. So that's going to be r squared minus r squared sine squared theta. So r squared minus r squared sine squared theta. And then again, showing you what's going on, it's dx, but dx is r cosine theta d theta. So times r cosine theta d theta. All right. Now let's simplify this a little bit. So I can factor out an r squared from both of these. And I can just take the square root of r squared, which is r, and r is just some number, so I can put that outside of the integral. So put it there with the 2. So the integral of negative pi over 2 to pi over 2. Now, when I factor out this r, what I'm left with would be 1 minus sine squared theta. Well, 1 minus sine squared theta is cosine squared theta. And the square root of cosine squared theta is cosine theta. So this would be cosine theta times, now I have an r here as well, which I can just take out as well. So I'm going to move this r outside as well and just put an r squared there. And it's going to be cosine theta times cosine theta. That's cosine squared theta d theta. All right. So we just need to find this integral. And so typically to find an integral, something like this, we can use power reducing identity. I'm gonna be honest, I don't remember the power reducing identity for cosine, but I can figure it out in a matter of seconds. And so that's the good thing about having a pretty good conceptual understanding of mathematical concepts. There's the less you actually need to memorize because you can just find what you need when you need it. So let me just figure out real quick, and I'm not being facetious. I really don't remember the power reducing formula for cosine, but I do know how to find it. So I'm going to use a cosine sum formula, which I'm going to say cosine 2 theta, which, you know, the cosine sum formula, you know, cosine of a plus b. I'm letting a and b be theta, so that's 2 theta, and that's cosine a times cosine b. So since they're both theta, that would be cosine squared theta minus sine a sine b, so that would be sine squared theta, since again a and b are sine. Sine squared theta is 1 minus cosine squared theta, so this is cosine squared theta minus 1 minus cosine squared theta, and this will be 2 cosine squared theta minus 1, and so that is cosine 2 theta there. And so if I solve this for cosine squared theta, I would add 1 and divide 2. And so that means that cosine squared theta is cosine 2 theta plus 1 divided by 2. So that's the power reducing identity there. And so what I'll do I have enough? No, I think it would be kind of messy to write it right here. So what I'll do is fit this in right here. Actually, I think I will fit it in, maybe just a different color. So I'm going to rewrite cosine squared theta as cosine 2 theta plus 1 over 2. Now notice this over 2, when I'm plugging in, it's going to be over 2, but there's a 2 right here, so those 2's would cancel. So basically what I would have is r squared, the integral from negative pi over 2 to pi over 2 of cosine, ooh, that's cos. Yeah, so now I didn't have a lot of space, a lot of room to play with. So I think I need to move to a new sheet now. It's a valiant effort. So let me just continue what I was writing. So a equals r squared, the integral from negative pi over 2 to pi over 2. And again, just showing what I'm doing, so there's no smoke and mirrors here. So again, I'm plugging in this guy for cosine squared theta. The 2 here canceled out the 2 there. That's why that's r squared instead of 2r squared. And so what's going to be inside of this integral is going to be cosine 2 theta plus 1. All right, so cosine 2 theta plus 1 d theta. All right, so now it can be easily integrated. R squared. The integral of cosine 2 theta is 1/2 sine 2 theta. And the integral of 1 is theta. And that's to be evaluated from negative pi over 2 to positive pi over 2. All right. Now, one thing, so we're going to, of course, plug pi over 2 and then plug in negative pi over 2 and take the difference. One thing to understand, when I plug in pi over 2 or negative pi over 2 into this expression, I'll be taking the sign of either pi or the sign of negative pi when this pi over 2 or negative pi over 2 is multiplied by 2. Sign of pi and sign of negative pi are both 0. So that's going to zero out. So really, everything is occurring from just this theta. So therefore, let me just do the theta. So first thing I'll plug in is pi over 2 for theta, and I will get pi over 2, and then minus, then negative pi over 2, so negative pi over 2. And pi over 2 minus negative pi over 2 is pi over 2 plus pi over 2, which is pi, and it's pi r squared. All right, so there you have the formula for the area of a circle, and where we derived that the formula for the area of a circle is indeed, has been verified and confirmed and corroborated, is indeed pi r squared. And it was a little bit to get to that particular result, but it was a very fun journey. All right, let's do some more. I can't get enough of this stuff. So let's find the area or derive the area of, say, a triangle using calculus, of course. And so this is some Cartesian plane here, and I'll graph some function. Where's my other pen? So this is, I'll say this is the function f of x equals mx. And so we'll go from 0 to b, and we'll call this distance here h, and h is just the value of f of b. And m, of course, is the slope, and and this will be important later, the slope here, as you can clearly see, rise over run, would be h over b. All right, so basically we're going to find the area under the curve of this guy, and we understand that the supposed formula for the area of a triangle is 1/2 base times height, or the base times height over 2. All right, so we're going to see if that result occurs. All right, so for this area, we're going to integrate from 0 to b the function mx. So mx dx. And m is just some number, and so it's a pretty easy integral. And so this would be m times x squared over 2 to be evaluated from 0 to b. 0 is just going to make it 0. So the only thing we have to plug in is b, and we plug in b, we'll get m times b squared over 2. And I know what you're saying. That looks nothing like the formula for the area of a triangle, but we have to remember what m is. What's m? M is m is h over b. So if I substitute that value for m, so if I turn m into h over b times b squared over 2, so this b would turn that b squared into a b, and we have h times b, but I'll put the b first, and so b times h over 2. And so the area of a triangle is the base times height divided by 2. So there we have derived the formula for the area of a triangle. That one went a little quicker than the area of a circle. Let's keep the game going. I like the game. So let's next do, let's say the area of a rectangle. So this is some Cartesian plane here, and we'll do some curve. So this is the area of a rectangle. So let's say, I don't want to call this the length because I don't want to use the letter L. So so let's call this the height. So let's say this is the function f of x equals h, where h is some number, and we're going to find the area from 0 to w. All right, and so I'm calling this height and width. And you know, the area of a rectangle is just width times height, if we're calling this height and width. All right, so what we'll do is we'll find the area under the curve of this function from 0 to w. So we're claiming that the area is the integral from 0 to w of h dx. Again, h is just some number, and so its integral is hx to be evaluated from 0 to w. Plugging in 0 is just going to make it 0, so we just plug in w, and we'll get h w. And again, confirming the formula, the area is the height times the width. All right, and the last two were probably too elementary, so let's spice it up a little bit. I don't know how much more spicy this will be, but let's do a volume problem. Let's do the volume of a sphere, and a sphere, the volume of a sphere is 4 over 3 pi r cubed. So what we'll do, and just bring back our first example. So if you remember our first example, we had this equation of a semicircle, the square root of r squared minus x squared. Well, we'll revolve this guy about the x-axis, and that will create a sphere. And so we'll see if we indeed get the correct formula. So what we're going to do is just do the disk method by revolving this curve about the x-axis, and we'll integrate from negative r to r. All right, so let's do that. So the disk method tells us that the volume would be pi times the integral from negative r to r. Now, actually, it's going to be easier than the circle formula because the disk method asks us to square this function. So we're going to get rid of the radical. So we're going to be integrating r squared minus x squared. And again, remember, r is just some number. So r squared minus x squared dx. And so if we go ahead and do the integration, the integrate of, again, r is some number. So the integral of r squared is just r squared x. And the integral of x squared is x cubed over 3 to be evaluated from negative r to r. All right, so let's plug this junk in. So pi. And so let's first plug in r and for x. And so that would give me r cubed initially, r cubed. And here it would give me minus r cubed over 3 minus. Now let's plug in negative r for x. That would give me negative r cubed, and positive r cubed over 3, positive r cubed over 3. Okay, cool. Now let's do the arithmetic. So we'll have, and there's still a pi there, we'll have r cubed minus negative r cubed, so that's 2r cubed. And we'll have negative r cubed over 3 minus r cubed over 3, so that's minus 2r cubed over 3. Again, still times pi. And we want to make this have a denominator of 3, so that would be 6 r cubed over 3 minus 2 r cubed over 3, which would give us 4 r cubed over 3 times pi, 4 over 3 pi r cubed. All right, so there we validated the formula for the volume of a, what did we just do? Volume of a sphere. Please forgive me, I actually forgot what we were doing. Let's do one last one. I'm actually kind of out of paper. I have paper in a different room that I don't feel like going to right now. So what I'll do is use the back of this. Hopefully it's still clear. All right. And so last, I just want to do the volume of a cylinder. The formula for the volume of a cylinder is pi r squared h. And so this is, let's draw another XY plane. Okay, and so we'll have some function where f of x equals r. And so that would represent the radius of this cylinder. And we'll go from 0 to h. And that, of course, will represent the height. And again, the formula is pi r squared h. Now, again, we're going to use disk method to create the cylinder, to create the right circular cylinder. We're going to revolve this guy about the x-axis. So the volume thus would be pi times the integral from 0 to h of this function squared of r squared dx, which if you integrate that, that's just going to be r squared x to be a value from 0 to h. And 0 is just going to give you 0. Now, and just for the elementary learners, every time you plug in 0 to the value in here, it's not going to give you 0. It will if it's a polynomial, but if it's some type of trigonometric function like cosine or something like that, it's not going to give you 0. So don't think every time it's 0, it's going to be 0. It's just happened. These guys in here have been polynomials, so that's been the case. All right, but anyway, so all we're going to plug in is h. And when I plug in h, that'll be r squared h in times pi. So pi r squared h. All right, so we derived a few of the geometry formulas you're familiar with, utilizing calculus, utilizing area under the curve, and the disk method. Hopefully you found this enjoyable, and we will see you next time.
Specialized in science and math, original black men, busting thoughts that pierce your mental, the fierce, ripping your section. Vocal toe-to-toe, impeccable, splitting your back, son. Simple as addition and subtraction, black thought, the infinite relax one.